Hello, good evening everybody. Welcome back to a new video. And in today's video, we are going to discuss about the Arrhenius theory of acid and bases. And part one, in the previous lecture of acid and bases, we discussed that the the very initial theory of the acid and bases, and that was termed as the classical theory of acid and bases. And if you haven't checked out that video, do check that out. While in today's video, we are discussing something with more latest, more say the updated version of the classical theory. Uh, so without wasting time, let's start. But before that, I would just like to say that don't think like this is the final theory, because there are several theories being presented. So after the classical theory, the Arrhenius theory was presented, right? Okay, okay, let's start. First of all, you're gonna see in this man on his own name has got named this theory as well, Arrhenius, and this is the man. This was scientist, and he was a Swedish scientist or chemist. You're gonna say, right? Uh, his full name is over here, Arrhenius or Sivenente or whatever that is. Proposed the first definition of acid and bases. A proper a theory based calculation definition was properly presented by Arrhenius. Like the classic was something which was not that much formal, but this was a formal statement of the acid and bases for the very first time. And substances A and B became known as acid and bases. It is just identify the acid and bases according to Arrhenius model. Acids are substance that dissociate in water. Now this is very important. Just marking the points. That dissociate in water. Acids are substance which dissociate in water to produce H plus ion. Whenever the conclusion is whenever they will dissociate, whenever just are into the water, they will dissociate into ions, probably the H positive ions. And base, on the other hand, are substances that dissociate into water to produce OH negative ions, right? So this theory is quite simple, right? It's simply saying the hydrogen is the one which is producing H plus ions, sorry, the acid is the one which is producing H plus ion in the aqueous medium, while the aqueous medium a solution, while the base is a substance which produces OH negative ions in a solution, right? Here we have got the examples of acid and bases, like whenever we have got NaOH in aqueous form, you will have Na positive ions and OH negative ions. The OH is produced, this is the reason why it is called a base. While in the HCl case, it is in aqueous medium, H plus ion is generated, Cl negative is generated, H plus presents that this is acid, right? Again, we have just looking for the same statements, which when substance, okay, H plus ions in solution, bases are the one with OH ion solution. Neutralization is something, this is a kind of reaction which happens because hydrogen ions and OH negative ions react to produce water. Now, uh, these say that if we have got a base and we have got OH negative of this, if you got an acid or H positive of this, now when these acid plus base will react, right, they will react, the OH negative and the H positive of both the substances will react to form water, right? Water will be formed, and this reaction is termed as neutralization. And along with the water, the salt would be formed as well. Now this would be our next a part of this chapter topics as well. So I'm not going in that detail, but they will produce water whenever they will react. And again the same statement, and here we have got HBr and this and KOH. Now here we have got water being produced. Now this shows water plus salt, acid plus base. This is an example of the previous statement. Or you're gonna say that if you're talking about a salt is an ionic compound, because this is composed of the ions H positive and negative, and it's formed by the reaction of acid and bases. We've discussed this. Example of Arrhenius acid, HCl, we discussed this. NaOH is a base and we produce these ions. Now before concluding the video, I would like to say that there are some sort of limitations. there's some sort of limitations for this as well. Now if you are observing the whole lecture, you're gonna find that this is only limited to aqueous medium, right? Aqueous medium, this means that this is only possible in water. The we can only, if we do not have water, how we are going to determine. So here comes the limitation of the theory. It doesn't explain the acidic nature of the substances which don't include H positive. Now this is something very important. Even though on that time there were very less substances, it maybe was known like the H positive are the only compounds which are acids, but that is not true. And this theory was unable to explain that, because this theory only includes the H positive ions. So the substances or the acids without H positive were unidentified. For suppose, if we take an example, we will find that FeSO4, this is an acid, FeSO4, right? So what about this? This theory cannot of course explain it. There is no production of H positive ions in the aqueous medium of this substance. It doesn't explain the basic nature of other substances as well, which do not contain the OH negative group. Now I do hope that you're getting the concept. OH negative is not produced, and H positive is not produced. Okay, the example for this is NH3 ammonia. It is of basic nature, but it does not produce OH negative, because there is even not a compound present, not an atom present. So I do hope that you got it. Like, this is a factor on which the theory lacks. And on this theory there was something, observation done, and there were experiments, and there were conclusion of new theories, probably, which we're gonna discuss on the next video. That would be Bronsted law, the theory for the acid and bases. So I do hope you got the concept. If you did, do like the video. Meet you guys in the next video. Till that, goodbye.